Okay, hi everybody. This is the notes for those of you that were taking the test or those of you that were on vacation early. I hope you're enjoying yourselves. It's 30 degrees outside and windy. Um, so, Chapter 9, we are talking about transformations. In this first part, I'm putting 9.1 there because that's the section that deals with the translations. But I'm not really going to be following the book as far as section 1, 2, 3. But I'm putting it there for a reference. So, we're talking about translations. Another name for that is a shift. For all transformations, we got these two terms here, pre-image and image. Okay? A transformation is taking one object and moving it to another object. So the pre-image is what you start with, the image is what you get after it's been moved. All right. So let me go to this one. So in this first drawing here, what we're talking about is a translation. It's a shift. So I'm just going to start with triangle ABC. Now you'll notice this line down here, this line DE. That is called a vector, and I'll talk about that more in a little bit. But the vector is describing what direction we're going to shift this triangle and how much we're going to shift it. Okay, that's what vectors do, is they talk about those two things, a direction and it's called a magnitude, but really in this case it's a distance. So we're going to take this triangle ABC and shift it the direction that D to E is going. You can kind of see the arrow there by point E, and that same distance. And so that is that triangle. Now what I'm going to do is click on point E and move it around. And you can see how when I move this vector, it's changing where that image is. The first triangle that we started with, this triangle ABC, that is our pre-image. Once it's been translated, we get our image. Okay, that's the triangle A prime. You see a little apostrophe kind of thing there, it's called a prime. There's a B prime, ignore that one, that's just part of the program, and a C prime. Okay, that's how you label your image points. So that's what this vector is doing, is it's telling us what direction to shift and how far to shift. So I'm going to connect these corresponding points. Okay, B to B prime, A to A prime, C to C prime. Now what I'm going to do is grab onto this vector, and you'll notice how these red markers, these red dashed lines, that vector fits perfectly over it. Okay, the vector is telling us how far we are shifting each of those points and in what direction. So this is a translation. Now there's some more stuff that goes with it. You'll notice, let's go back to the drawing, sorry. You'll notice that these two triangles, they're exactly the same. Okay, the distances are the same of each segment, so we got side, side, side. But a pre-image and an image, in this case, they're identical to each other. And so that is called an isometry. It is a transformation that preserves the length and angle measurement. All right, basically what we're saying is the pre-image and the image, they're exactly the same, they're congruent to each other. So, an isometry, it is a transformation that keeps, or that makes the objects congruent, or keeps the objects the same. Okay, so a translation, it is an isometry. Now, there are some different ways to write the notation for a translation. Okay, one of them is a rule. Sometimes it's called a map, or we're mapping these points. But what we have, we're starting here at a generic point xy. This is the coordinates of our pre-image. The arrow means it's getting moved to a new position. This is the coordinates for our image. Okay, so when we're doing a translation, all we're doing is either adding or subtracting from our x values, moving it left or right, and adding or subtracting from our y values, moving it up or down. Okay, let's go back to this drawing. And so what we're doing is, in this instance, we are drawing from point D. Remember, this vector told us what direction and how far we're going. So in this case, if I just leave vector DE the way it is, we went 1, 2, 3, 4 units to the right and 1 unit up. So that rule would be written like this. Okay, to go from the original x-coordinate to the new one, we added 4 to that. And so if you think about this at point A, our x-coordinate is at -1. At point A prime, our x-coordinate is at 3. -1 plus 4 is 3. The y-coordinate, we went up 1. So we're going to go y plus 1. Okay? The y-coordinate at point A is at 2. The y-coordinate at point A prime is at 3. 2 plus 1 is 3. So this is our rule, okay, the whole thing. All right. And so this is how you write it. If we're shifting to the left, it would be x minus a number. If we're shifting down, it would be y minus a number. But we always write it this way. We're starting at a generic xy with the arrow going to this new point. That's called a rule. Take a second and hit pause. You're going to want to copy this stuff down. The other way to talk about how to express a translation is with vectors. So, a vector, it tells you a direction and a magnitude, like I mentioned earlier in that other drawing. A couple of things with a vector is you start at an initial point. Oops, that's this circle here. Well, I can't get the cursor to move here. I don't know why that finger's not moving. But the initial point is where the vector starts. The terminal point is where the vector ends. The terminal point is where that arrow is, looking at that red arrow. A vector is made up of 2 parts. Its horizontal component and its vertical component. It's very much like slope. That's essentially what it is. We are going a certain distance in the horizontal, so in this case it's 5, and then a certain distance in the vertical direction. In this case it's 3. So, I mean, it's essentially slope. It's also a way to tell us distance. We just do Pythagorean theorem. 5 squared plus 3 squared, that's going to be the square root of 34. So that's how far this object would be shifted if we were using that vector. Okay, so now, component form for a vector. Shorthand notation, like it says. But the key thing here is those brackets. That is specific to vector notation. And it's just like a point. How much are we moving in the x direction? How much are we moving in the y direction? So in this case, this vector is 5, 3. Okay, with those brackets. Now, vectors are usually named, I used A, B there, but they're usually named with a lowercase letter and this notation. It's kind of like a weird arrow, just a half arrow kind of idea. That's the notation for a vector. So just to talk about some other vectors, let me change this point to be here. So now the component form for this vector would be, we're going horizontally 5, but now we're going down 1. So our vector component for this one would be 5, -1. Whoops, bracket. I didn't want that parenthesis. Okay, that's the idea of vector components. Now, vector component in the rules, they're almost identical. Okay, we're starting at a generic point x, y, and we're going to the terminal point here where we would have to add 5 to the x and subtract 1 from the y's. So the rule would be this. The vector is 5, -1. Okay, there's a direct correlation between those numbers. It's describing the motion of that translation. Okay, I already put this on the website. The blank sheet, blank homework assignment is there. These are the directions for all the problems. If you have questions as you're in Florida laying at the beach, feel free to email me and I'll get back with you. Have a good time.